Welcome everybody to Unit 4, where we are going to be talking about neural networks. So neural networks are a very exciting part of machine learning. This is actually where a lot of the current research is at, especially when you bring up topics such as artificial intelligence or deep learning. This is usually what's being talked about, and that is neural networks. So we are going to cover them in depth this unit and talk about some of their different features and different applications. And so hopefully by the end of this you will know how neural networks work, how to apply neural networks to problems, and how to train them and use them in your day-to-day work. So let's take a look at what we're going to cover in this unit. Once again, this is just video 1, and that's going to cover an introduction to neural networks. Broad overview, what are they, what do they contain. In number 2, we're going to talk about the perceptron, which is essentially the basic processing unit of these networks. Could also be called the neuron. The neuron is actually a generalized version of the perceptron, but we'll cover it in depth there. We'll talk about the backpropagation algorithm in our third video, which is what is used to train neural networks. In that video, we'll talk about topics such as gradient descent and have a nonlinear regression example of that. In video 4, probably the most useful video, we'll talk about the training procedures. Things like parameters, activation functions, how to ensure convergence, overtraining, undertraining, that type of thing. So that video will cover in large part what you need to know when you're trying to apply neural networks to your projects. Number 5 is the convolutional neural network, and this is a very exciting subclass of neural networks that are used in image processing applications. So convolutional neural networks cover a lot of the current research and also include some of the exciting aspects of deep learning. So when we cover that, we'll talk about pixel-wise segmentation, which is a common computer vision task, and then we'll also talk about deep learning and the image representations that occur in deep learning that have everybody so excited. But for now, let's just dive right into this first video, and that is an introduction to neural networks. Once again, this is presented by EDU Onyx. Thank you for listening. Hopefully this can teach you something useful in your day-to-day work. So what is the neural net, or more properly called the artificial neural network? The neural network is essentially a computing system made up of a number of simple, highly interconnected processing elements which process information by their dynamic state response to external inputs. This is a quote from Dr. Robert Heck Nielsen, who was the maker of one of the first neural computers. So he has an understanding of what they are, but let's cover some of the basics. The neural net is modeled after the neuronal structure of the mammalian cerebral cortex. So when we mentioned before that machine learning isn't actually studying neuroscience or something of that nature, the overlap is in neural nets, and there are actually cognitive scientists and neuroscientists whose aim is to understand the functioning of the brain, and towards this aim build models of the natural neural networks in the brain and make simulation studies. And so we have an overlap between computer science and cognitive science in neural networks because they are modeled after the brain. And this is, again, why they're called artificial neural networks. An actual neural network is what occurs in your own mind, and so we're trying to represent artificial versions of that. So engineers are interested in neural networks because we believe that they may help us build better computer systems. So there's no guarantee that the brain is the best way to build an ideal computer system, much in the same way that we have jet planes, and jet planes don't have feathers despite all birds, well, I guess you have bats, but most birds in biology having feathers. So things like interconnectivity and synapses may not be important for our overall function. However, for right now, we're trying to model them in these computer systems because it seems like a good way to go and it's having a lot of success. So, but despite all that, neural networks are still nonlinear statistical models. So it's still a statistical model. It doesn't think or understand in the way that you and I do, but it can model nonlinear scenarios. So in simple cases, it can actually be used as a linear binary classifier as well. But typically, it's nonlinear, and we'll explore why that is in one of the later videos. It's also a non-parametric estimator. So we are not going to assume underlying functions when we're designing these models, such as a linear model or a nonlinear model. We are going to let the neural network do that itself. And finally, it can be used for both classification and regression tasks. So neural networks are very broad and they can be applied to a lot of things. And finally, backpropagation algorithm is used for training. So backpropagation is huge for neural networks because originally we had the neural networks but no way to teach them what to do. And so they sat around for a while until we applied this math to the training procedure. So we'll talk about backpropagation in a lot more depth later. So now you have some of the basics. Let's take a look at the elements of the neural network. And these are pretty straightforward. You have neurons, and those neurons are organized into layers. These are the essential elements of the neural network. Now, in these, we have some more details, and we'll talk about the details of neurons and the details of layers now so that you can understand what's going on much better. So the artificial neuron is modeled after a biological neuron. So a neuron receives inputs. The biological neuron receives a lot of inputs through its dendrites. It processes that information, and if it reaches a certain threshold potential, it transfers that signal down the axon into its synapses, which connect to additional neurons. In much the same way, we have the artificial neuron, which takes a summation of inputs and multiplies them times their weights. And the weights can be thought of as the strength of connection. So input with a large weight is going to have a larger representation in the final output than an input with a small weight. We also have what's called a bias value. And the bias value is typically just 1, and this is to ensure the ability of the network to generalize to new information. And so we'll talk more about bias values later. So in our artificial neuron, we also have what's called an activation function. So once we sum up the inputs times their weights, as well as our bias, we process them with an activation function, which essentially acts as a threshold, much like you have in the biological neuron when you have a threshold potential. And if we meet that activation function, we meet that threshold, we will produce an output, which is passed down along the line. So that's the artificial neuron. Artificial neurons are organized in what we call layers. So these layers are made up of a number of interconnected nodes or neurons which each contain an activation function. So we're going to have the input layer, and the input layer isn't going to have any processing, although it may be normalized. It's typically going to be normalized. And we can have any number of inputs. If we are processing an image, even if it's just a 100 pixel by 100 pixel image, we are going to have 10,000 inputs. So you can kind of conceptualize how quickly these neural networks will expand and get much larger. Each one of those inputs is connected to a node in what is called the hidden layer. If there's a layer between the input and output, it's called a hidden layer. You can have typically one hidden layer, but we'll see in deep learning applications you actually have multiple hidden layers. And that hidden layer is where the actual processing is done. And it's done via this system of weighted connections. So if in our hidden layer we're going to process the inputs times their weights, we're going to have biases, and then we're going to use an activation function to produce an output. And so the output is going to receive connections from all of the hidden nodes again. And this diagram here is showing 2 outputs. But we could also, for example, in regression tasks only have one output, and it would be maybe a numerical output, or we could have many outputs if we had a multi-class problem. And so this is the general organization of a neural network. There's going to be processing. This actually diagram right here is a 2-layer network. We don't consider the inputs because there's no processing done. But there's going to be processing in the hidden layer, and there's going to be processing in the output layer. Each time the inputs and the weights are going to be summed and then processed with an activation function or a thresholding function to produce an output. And so we'll look at how these are trained in depth later, and they're trained again with the backpropagation algorithm. So that's going to be actually our 3rd video, although we're going to talk about it a little bit in our second video when we talk about the perceptron or the neuron. Again, perceptrons and neurons are similar. Neurons are just a generalization of the perceptron, and each one of the nodes in this diagram are going to be a neuron or a perceptron. So in this hidden layer, you have 4 nodes. In the output layer, 2 nodes. Each of those acts in the same way as our artificial neuron in the previous diagram. So this is the basic structure. When they get a lot more complicated and look a little bit like this, they're considered deep neural networks. And so a lot of people get really excited by artificial intelligence, and this is the area where machine learning and artificial intelligence overlap. When we have multiple hidden layers, we have what we call a deep neural network, and it is able to do deep learning. So in these hidden layers, we're going to get abstract representations of the data, which are what people are all excited about. It's not necessarily the ability to produce the output, it's the network's ability to build these different representations of the data and really kind of perform what some people would argue is a type of thinking. But we'll explore that a little bit later, because once again, these are still statistical models. They're nonlinear statistical models. And so most of the rules that we talked about in the previous units still apply to what we're talking about here. But we will actually explore deep neural networks a little bit later. The final project is going to be a deep neural network, so you'll get some actual hands-on experience looking at some of these and what they can do. So in summary, neural networks are non-parametric estimators or nonlinear statistical models, and they can be used for both classification and regression tasks. So very broad, can be used in a lot of different scenarios, but neural networks basically are simply composed of neurons, and those neurons are organized into layers. Finally, a deep neural network has multiple hidden layers. So this is just an introduction. Hopefully it was quick, gives you a general idea. In our next video, we're going to dive into the perceptron, which is the basic processing unit, basically a neuron, a generalized version of the neuron. And then after that, we're going to start talking about how we actually teach these neural networks to learn and what that process looks like. Thanks for listening.